Hi everyone. So today's topic for discussion is visualizing the large data sets with Hexbin and density plots. So we are going to see two types of plots over there, Hexbin and density for visualizing the large data sets. So here we will create random data sets with random values like 1 lakh values or one with 1 lakh records. We will create a data set and we'll see how these plots works. Okay, so when we need to work with or whenever we are working with a large data set, visualizing them effectively can be a challenging or that may be a limitation. So these two types of plots like Hexbin and density plots are powerful tools that can help to reveal the patterns, trends, and like relationship in such data. So relationship between the like input variable and output variable, those we can see for the large data sets. So these two plots are useful in order to visualize the large data sets or like continuous data whenever there is a continuous data points or records. So Hexbin plot, that is like that groups the data points into the hexagonal bins and color code. So these are the based on the color codes, and these bins are based on the number of data points they contain. So according to number of data points, that color will change, and color code as well as number of bins will be associated. So this method is particularly useful when the scatter plot or regular scatter plot is not sufficient or like is it is very difficult to analyze by using the scatter plot, and it is scatter plot giving the like dense nature or dense graph, so it is difficult to interpret or like to get the results to find out the insights from it. So if we talk about key features of a Hexbin plot, so it reduces the overplotting in the dense areas. Okay, so that is the like advantage of this Hexbin plot. So it highlights the like concentration of data points. Also, it is efficient for the large data set. So those are like key features for the Hexbin plot. So here we have considered one small use case by using the Python and matplotlib library. So we have just imported the two libraries here from the Python, like matplotlib.pyplot as a PLT and numerical Python numpy as a NP. We are going to generate a sample data set. So X values I'm taking as a random normally distributed values by using the function from the numpy module, that is a random.randn. So 1 lakh values I will generate for X as well as Y, and I'm going to visualize those values with the help of Hexbin plot. So in order to create a Hexbin plot, I just use the like figure function from the matplotlib.pyplot library. So fixed size, obviously we can change these values. As of now, I'm taking these values as 8 and 6, so that resolution for my graph will be proper. Okay, so after that, like parameters for Hexbin, or I'm calling like Hexbin plot from the PLT. So different parameters are there, obviously, input values, output values, along with the grid size, CMAP, minimum count. So these are the parameters. If you are interested, you can go into the other parameter as well, and description for the all parameters. So different parameters are, some of there are like default values, somewhere you can change. Suppose grid size by default value is 100, we are taking as a 50. Okay, CMAP, the color value we are taking as a like blues, right? So minimum count we have taken as a 1. So this is the minimum count required to color a bin. Okay, so these values you can take obviously by using the like shift tab. You can check the all the parameters. So plt.color bar, so label for the color bar will be like data point count. So that will come on the right side of my graph. And plt.title, obviously these are like regular things that we use for any plot generation. So title, that is like just a heading for the plot. X label, that is the X label values. Okay, so here I'm just giving the X axis and Y axis as of now. If you have any particular label like salary or like experience, you can give those. So if we generate the plot, I will get a plot like this where beans are like generated with the color as a blue, and we will get the distribution. Okay, so it is useful whenever scatter plot is not working properly, or like whenever it is too dense to generate the result by using the scatter plot. So this all about like Hexbin plot. Second type of plot that we are going to see, that is the density plot. So it estimates the distribution of a data by using the kernel density estimation or KDE. So this method is useful for visualizing the probability density of continuous variable. So mostly this is used for the continuous variable only. And density plot and the features like it provides the smooth representation of data density. Okay. Also, it is useful for identifying the modes and the data spread, how values are occurring frequently, and how the data is like spread, or how data is variance of data is there. So in that case, density plot is helpful. Also, it is effective for overlaying the multiple distributions. Okay, if multiple distributions are there, then density plot play an important role, right? So these are some key features for the density plot. Same as the Hexbin plot, we have implemented a small use case by using the Python and Matplotlib library. Okay, so we have just generated a data frame for the sample data frame for the 1 lakh values X and Y, and we are going to create a density plot. Fixed size I have taken same for the visualization like 8:6. In KD plot, I can provide the different parameters. So initially I need to provide the data. So that will be my data frame, correct? X as a X level values like input values, Y as a Y output values, C map that is a color, in which color I want, right? So different options are there, and field that is either I want the portion as a field one or like empty one. So I can give a field so that it fills the area under the density curve. Okay, C map you can use to like color map for the density levels. There are other functions as well, like you can change or you can adjust the bandwidth for the smoothing. Those things are there. And this title, X level, Y level, LD.show, these are the regular function those we are using for any type of plot. Okay, so by title I will get just a title for the my plot. X-axis like X variable, Y-axis for like Y variable. As of now, we are just taking X and Y. So you can take any particular example, right? So if we compare Hexbin plot and density plot, so as per the use case, Hexbin plot is best suited for large data set with dense areas, whereas density plot is suited for continuous distribution. Okay, and if we talk about like output, so for the Hexbin plot, hexagonal beans with the counts, that is our output. For density plot, we are getting smooth probability density curves. Okay, density curve we are getting in the density plot. We can customize the values for Hexbin plot like bin size, color map, minimum count. These values we can customize for the Hexbin plot as well. For like density plot, I can customize the bandwidth, color map, smoothing, these values for the density plot. If you talk about like use cases or applications, so for Hexbin plot, when the data set is very large, it is enormous, and the scatter plot are not readable. In that case, Hexbin plot play an important role. For example, geographic data is there, heat maps are there, then Hexbin plot is useful. Whereas in density plot, when the focus is on distribution or like density of the data, when we are considering the kernel density function over there, or density of the data, distribution, variance. So if we are considering these things, then density plot is important for the continuous data points, continuous variable. So if we have demographic data, financial modeling we are doing, then in that case, density plot play an important role. So that's all about like visualizing the data sets with the help of Hexbin plot and density plot. So that's all. Thank you. Bye bye.